The last time you used ChatGPT, you probably didn't think much about it. You typed something, waited a second, got your answer, and moved on. But that one interaction, that single question, consumed about 10 times more electricity than a regular Google search. Now multiply that by 1 billion people doing the same thing every single day. The numbers stop making sense pretty quickly, and the people who are responsible for running this infrastructure, Microsoft, Google, Amazon, Meta, they are all staring at the same terrifying problem right now, because the more powerful they make their AI, the more electricity it needs, and they are all trying to make it much more powerful. There is not enough electricity on the planet to power what they are building. But to understand why the electricity is running out, you first need to understand what AI actually consumes. And the answer is a lot stranger than you expect. Every time you use an AI tool, the actual thinking is done by something called a GPU, a specialized chip that's built very differently from anything inside your phone or laptop. The chip in your phone is designed to be efficient, drawing as little power as possible to keep your battery alive. A GPU built for AI is almost the exact opposite. It's designed to be brutally fast, processing enormous amounts of data simultaneously, and it pays for that speed and electricity. Take the NVIDIA H100, which is the chip powering most of today's AI systems. It costs around $30,000 per unit, and it draws roughly as much electricity as a washing machine running continuously. Not just during the spin cycle, but every hour of every day with no off switch. Now imagine you don't need one of those chips. You need 10,000 of them, all running simultaneously in the same building. That's what a modern AI data center looks like, and the scale of it is genuinely hard to picture until you try. Picture a building the size of 10 football fields placed side by side, with no windows, concrete walls, heavy security at the entrance, and inside, row after row after row of servers stretching further than you can see, all running at full capacity, all generating enormous amounts of heat 24 hours a day. The heat produced is so intense that these facilities need cooling infrastructure larger than most hospitals. Some of them pump millions of gallons of water through their systems every single day just to keep the chips from overheating. Microsoft's data center campus in Wisconsin, for example, uses enough water annually to supply a town of 75,000 people. And there are hundreds of these facilities operating around the world right now, with hundreds more currently under construction. Which brings us to the part that makes the electricity problem so difficult to solve. The AI models being trained right now aren't getting smaller or more efficient. They're getting larger with every generation. Every 18 months or so, the amount of computing power required to train the most advanced AI models roughly doubles. Which means more chips, which means more electricity, which means more heat, which means more water, and the whole chain compounds year after year with no natural ceiling in sight. And the grid that most of the world runs on was simply never designed to handle any of this. The electricity grid that powers most countries was designed in the 1960s and 70s, built for a world of homes, offices, and factories, not for individual buildings that consume as much power as a mid-sized city. And that mismatch is now becoming a serious problem. Virginia, which hosts more data centers than anywhere else on Earth, has already hit its limit. New applications are being turned down, not because of planning issues or money, but purely because there isn't enough electricity available to supply them. And Virginia is not alone. Ireland, the Netherlands, and Singapore have all started imposing restrictions on new data centers for exactly the same reason. The obvious question is, why not just build more power plants? And the answer reveals a structural problem that goes deeper than it first appears. Permitting a new power transmission line in the United States currently takes between 5 and 10 years on average, and building an entirely new power plant can take 15 years or more from planning to operation. AI companies, meanwhile, are signing data center contracts right now and expecting those facilities to be online within 12 to 18 months. Goldman Sachs estimated that data center electricity demand will grow by 160% before 2030, which is only 4 years away. To put that in perspective, it's the equivalent of adding the entire electricity consumption of Germany to the grid and directing all of it into data centers. The result is a scenario that's already playing out in parts of the world. Billions of dollars of AI hardware sitting ready to operate with no electricity available to actually turn it on. So the question becomes, what do you do when the grid says no and waiting isn't an option? You find another way. In 2023, Microsoft signed a deal to restart 3 Mile Island, the site of the worst nuclear accident in American history, which had been shut down and sealed off for over 20 years. Microsoft is bringing it back online specifically to power its AI infrastructure, and the move caused a lot of raised eyebrows at the time. But when you look at what the rest of the industry is doing, it starts to make complete sense. Google has signed contracts with companies building small modular nuclear reactors. Amazon acquired a nuclear-powered data center campus in Pennsylvania. And Sam Altman, the CEO of OpenAI, has personally invested over $375 million into a nuclear startup called Oklo. The reason they're all converging on nuclear isn't ideology, it's pure logic. Solar panels stop producing when the sun goes down. Wind turbines stop spinning when the air is calm. But an AI data center operates every second of every day, regardless of weather or time, which means it needs a power source that is constant, reliable, and capable of delivering enormous amounts of energy without interruption. Nuclear is currently the only energy source that meets all three of those requirements simultaneously. The problem is that a new nuclear reactor takes between 15 and 20 years to plan, permit, and build. The AI companies need power this year, not in 2040. So while the nuclear build-out gets underway, they've had to bridge the gap with whatever's available. And in many cases, what's available is coal. Microsoft's carbon emissions increased by 30% between 2020 and 2023, and the company has directly attributed most of that rise to the growth of its AI operations. Google reported a 48% increase in greenhouse gas emissions over the same period. These are the companies that have spent years making very public commitments to sustainability, and their own data shows they're moving in the wrong direction. The uncomfortable truth is that the companies promising to solve the world's problems with AI are, for the time being, making one of those problems measurably worse. And there's a dimension to this that almost nobody in the mainstream conversation is addressing. China is building AI data centers at a pace faster than any other country in the world, and China's electricity grid runs predominantly on coal. The global AI race isn't just a competition over who has the best algorithms or the most talented engineers. It's a competition over who can secure enough energy to keep their systems running. And right now, the country most willing to burn fossil fuels to win that race is also the one moving the fastest. Here's the thing that nobody's really saying out loud. AI is not going to slow down. The models will keep getting larger, the user base will keep growing, and every new application that emerges, AI in hospitals and legal systems and military infrastructure, adds another layer of demand on top of an already strained system. The electricity problem isn't a temporary bottleneck that the industry will quietly solve in a few years. It is actively reshaping the geopolitical landscape in ways that will matter for decades. Because energy has always been the foundation that power, real power, is built on. In the 1800s, the countries that controlled coal controlled the Industrial Revolution. In the 1900s, the countries that controlled oil controlled the global economy, and with it, enormous amounts of political influence. We are now moving into a world where the countries that can supply clean, reliable, large-scale electricity will be the ones that lead the development of AI, and the countries that fall behind on energy will find themselves falling behind on everything that AI makes possible. That's why this question isn't just an environmental debate or a technology story. It's a question of national infrastructure, of geopolitical positioning, and of who gets to shape what the next 100 years look like. The Industrial Revolution ran on coal. The 20th century ran on oil. The AI era will run on electricity. And right now, there isn't enough.